Welcome to another edition of Math Tutorials. In today's edition, we're going to take a look at graphing piecewise-defined functions. And here's an example of a piecewise-defined function. And our instructions here are to sketch the graph f of x equals 5 minus x for x less than or equal to 2, and f of x equals x plus 1 for x greater than 2. One thing to remember about this is if you ever get confused with the piecewise notation like this, when it shows you more than one piece, what it means is there's more than one equation, and one equation applies for a certain part of the graph, and another equation applies for a different part. So what this is telling us is f of x, which is also known as y equals 5 minus x is one of our equations, and it applies when x is less than or equal to 2. And the other equation is y equals x plus 1, and that applies if x is greater than 2. So the way I always start a piecewise graph is I take a look at what I call the switchover point. When does it switch from one equation to the other? And the first equation applies for x less than or equal to 2, and the other one for x greater than 2. So 2 is your switchover point. Okay? So what I do is I mark x equals 2 with a dashed vertical line here. This is not an asymptote, if you know what that is from rational graphing. It's just a mark here to indicate to myself where it switches from one of these graphs to the other. Now if I'm looking at x less than 2, that means over here, to the left of the mark I just made. And over here, the equation is y equals 5 minus x. So I write that over here for myself. Y is 5 minus x over here. On the other hand, if I go to the right, this side, x greater than 2, then the equation is y equals x plus 1. So over here, it's y equals x plus 1. So that's always the first thing I do, is I divide up the regions and figure out where one equation applies and where the other applies. Now if you look at the forms of these equations, each one is a line. This is y equals mx plus b, and this is, it's switched in order. You might be used to seeing the x first, y equals negative x plus 5, but it's a mx plus b, it's a line as well. So both of these are parts of lines. And one of the things that's characteristic of a line is I only need to know 2 points on the line to graph it. So that helps me know what I should be doing here and picking in order to sketch these pieces. Okay, so with that in mind, let's go ahead and start graphing these different pieces. And I'm going to just draw one at a time. So let's start on the left side. Let's start with y equals 5 minus x. And you could do this a number of ways, but I'm just going to do picking points because most of us are pretty comfortable with that. So just make xy table. And let's pick a few values of x and plug them in and just see what we get. But keep in mind there is a restriction because y is equal to 5 minus x only over here, only to the left of this dashed line that I made, then the x values I can pick have to be over here. Okay? So don't just go pick any x. I don't want to pick x to the right. I want to pick x's over here. So any x's over here will do, but I want to also, in particular, I want to pick one on this dashed line. I want to pick x equals 2 because I want to know where the line ends. So I'm going to pick x equals 0. So put 0 in for x here. 5 minus 0 is 5. So it goes through 0, 1, 2, 3, 4, 5 right there. And then I'm going to pick 2 because I want to know where it stops. So put x equals 2. When you put 2 in here, 5 minus 2 is 3. So it goes through 2, 1, 2, 3 right there on my dashed line. And because I have a line here, that's it. That's all I need. That tells me the full shape. So my line is going to go this way, like so. Okay? So that's the first piece, and that's really all there is to drawing the first piece of this graph. Now we're going to do a similar thing for the second piece over here. And I'm going to make a table for y equals x plus 1. And even though technically, if you look up here, it's not defined for x equals 2, That means it's going to be open at 2. I want to know where that open circle is going to be, so I'm going to pick 2 for x. And when I put 2 in for x, right here I get y equals 3. So if you go 2, 3, that's right where the other graph ended. So I have an open circle right there, but it connects. So it's open on my new piece, but it's actually filled in from the other piece. So I'll just draw an open circle there for the moment, and then pick some other x value over here on this side for x greater than 2. So maybe like 3 or 4. I'll pick 4. Put x equals 4 in here. 4 plus 1, I get 5. So it goes through 1, 2, 3, 4, 1, 2, 3, 4, 5. And then I'm just going to draw myself a line that connects those two dots. So here to here. And that's our picture. And in the final picture, some people wonder whether they have to show that open circle here. You don't actually, because these two pieces together form one graph. And while that's an open circle for the right piece, it's filled in by the left piece. And these actually connect to each other, forming one V shape. So I don't really even need that. It's just a V shape with no gaps in it. Okay? So that's the idea of sketching a piecewise defined graph. I start by figuring out where it switches from one piece to the other, which here's at x equals 2. I draw a dashed line from there, and then I identify which graph applies to which side of that dashed line, and I just graph them individually. And in this case, since they were lines, it was easy to use a t-table to do that. Okay, so this completes our tutorial on graphing piecewise defined functions.